We should observe it. It doesn't look like it's a random occurrence. The size, the trajectory, the fact that it comes so close to 3 planets in our source. And actually, it comes closest to the Sun on October 29th when the Earth would be on the other side of the Sun. We won't be able to observe it. It began as a faint point of light, another wandering speck detected on the edge of our solar system. Astronomers noted its presence, logged its trajectory, and at first treated it as they always do, just another comet making a fleeting visit before vanishing back into interstellar darkness. But within weeks, the ordinary turned extraordinary. The object, now known as 3 Atlas, was no simple comet. Its path bent in strange ways, its movement pulsed with unnerving precision. And the deeper scientists looked, the stranger it appeared. 3 Atlas was different. Unlike its predecessors, Oumuamua and 2I Borisov, it seemed to carry secrets that refused to stay quiet. Its course through the solar system wasn't random. It appeared to weave deliberately toward 3 planets, Mars, Venus, and Jupiter, threading a path that defied the odds of chance. And even more unsettling, it began to show signs of behavior that looked less like natural physics and more like control. From the moment these anomalies came to light, speculation ignited. Was 3I Atlas an unusually volatile comet behaving in ways we had never seen? Or could it be something entirely different? Something built, something sent, something that would force humanity to confront the possibility that we are not alone. NASA's tracking data provided the first hints that 3I Atlas was unusual. The plotted trajectory, a clean curve at first glance, concealed small deviations that were difficult to explain. Normally, comets shed gas and dust when warmed by sunlight, producing jets that can nudge them off course. But 3 Atlas's deviations weren't random spurts. They lined up with a bizarre rhythm. Every 17 minutes, without fail, the object emitted what appeared to be bursts of energy. With each burst, its course shifted slightly. To some observers, this was less like a natural outgassing and more like a spacecraft firing thrusters. The idea was so outlandish that most scientists hesitated even to voice it. Yet, the pattern was there, repeating with the kind of precision nature rarely produces. Skeptics urged caution. Perhaps there was a still unknown physical process at work. Perhaps the data were being misread. But the coincidence was troubling, and the more it was studied, the more difficult it became to dismiss. One voice that rose above the noise was Avi Loeb, the Harvard astrophysicist who had already stirred controversy by suggesting Oumuamua might be artificial. Loeb has built a reputation as both a respected scientist and a provocator, unafraid to push boundaries when the evidence appears to demand it. With 3 Atlas, Loeb noted a series of probabilities that strained belief. The chance of an interstellar object aligning so closely with the orbital plane of the planets is about 1 in 500. That alone is remarkable. But the odds of its trajectory taking it past 3 major planets, Mars, Venus, and Jupiter, in such a tight sequence, roughly 1 in 20,000. At some point, coincidence begins to look like intent. Loeb asked the question many were already whispering. Could 3 Atlas's path have been chosen? If so, why those planets? The answer, he suggested, might lie in their shared qualities. Mars, with its dust storms and history of exploration, is the most studied terrestrial neighbor. Venus, though hostile and shrouded in clouds, is Earth's twin in size and composition, making it scientifically irresistible. Jupiter, massive and turbulent, dominates the solar system with its gravity and its swirling storms. All 3 worlds possess significant atmospheres, distinguishing them from Mercury, Uranus, Neptune, and even Saturn, whose iconic rings overshadow its atmospheric features in the public imagination. They're also bright, easily visible to the naked eye, and culturally significant, having shaped myths and calendars for millennia. If an interstellar probe were designed to study representative planets of a system, these 3 would be natural choices. The strangeness of 3 Atlas was not limited to its path. Loeb introduced a scale ranging from 0 to 10 to classify the likelihood that an object might be artificial. A 0 means a normal comet unworthy of suspicion. A 10 would be undeniable evidence of alien technology. 3 Atlas earned a 4. That rating may sound modest, but in context, it is startling. It means the object exhibits multiple persistent anomalies, unexplained accelerations, spectral signatures that don't match known asteroid types, and a trajectory suggestively aligned with planets. A 4 is not proof, but it is a strong signal that something here does not add up. More data only deepen the mystery. Observers reported that 3I Atlas sometimes slowed down when gravity suggested it should accelerate and sped up where it shouldn't slowed. In gravitational terms, it behaved backwards. Combined with the 17-minute pulses, these speed anomalies fueled the sense that the object was not passively drifting, but actively adjusting. Theories spread. Was it stabilizing itself, correcting course, or was the appearance of control and illusion created by forces we do not yet understand? The possibility of a collision added a level of urgency to the debate that had not been present before. In the early days of observation, orbital models indicated that 3 Atlas would pass safely by Mars, curving around the planet in a graceful arc before slingshotting back into the darkness of interstellar space. It was a scenario familiar to astronomers. A harmless visitor grazing the inner solar system, an event significant for science, but benign in its consequences. Yet, as more data poured in and refinements were made to the calculations, the certainty began to fray. Small deviations in the object's path suggested that its trajectory was tightening. The difference was subtle, but in celestial mechanics, even the smallest changes in speed or direction can transform a near miss into a direct hit. At its immense velocity, an estimated 87 km/second, 3I Atlas carries with it an almost incomprehensible amount of kinetic energy. A collision with Mars would not resemble the gradual erosion of landscapes that we associate with geological time, but rather an instantaneous release of power rivaling millions of the most powerful nuclear devices humanity has ever imagined. The impact would gouge a crater roughly 60 kilometers across, reshaping entire regions of the Martian surface in a single moment. Vast plumes of dust and debris would be launched skyward, darkening the planet's thin atmosphere and perhaps altering its climate for decades. Mars, already a world of fragile balance, could find its delicate atmospheric envelope further destabilized, making the planet even more inhospitable than it already is. The devastation would not be limited to the surface. Mars is encircled by a fleet of spacecraft, orbiters, rovers, and landers that represent decades of international exploration and billions of dollars of investment. These machines are humanity's outposts on another world, our eyes and hands reaching across interplanetary space. A collision of this scale would almost certainly wipe out much of that robotic presence. Orbiters could be torn apart by debris, their signals falling silent in an instant. Rovers on the surface could be buried beneath falling dust or rendered inert by seismic shock waves rippling through the crust. In one catastrophic event, a cornerstone of our scientific exploration could be obliterated. Even more troubling are the cascading effects such an impact might produce. Ejected material from the strike would not remain confined to Mars. Fragments of rock and metal hurled into space at tremendous speeds could form a cloud of debris spreading across the planet's orbit. Some of this material might eventually intersect with Earth's trajectory, raising the specter of secondary impacts closer to home. The timeline for such threats would be measured in years, or even centuries. But the seeds of a new hazard could be sown in an instant. This was no longer just a Martian problem. It had the potential to become a planetary, even a species-wide concern. The technical warnings were alarming enough, but behind them simmered an unease of a different kind. If 3I Atlas truly were artificial or even partially controlled, then a collision with Mars might not be a random outcome of celestial mechanics at all. The 17-minute bursts, the improbable trajectory, the statistical unlikelihood of its planetary encounters, these were difficult to reconcile with the notion of a mindless rock wandering through space. If intent were involved, then the implications grew darker. Was Mars the target of a deliberate strike? Was this the prelude to something larger, or merely the byproduct of reconnaissance gone airy? Speculation filled the void left by uncertainty. Some envisioned 3I Atlas as a probe, perhaps scattering smaller devices into planetary atmospheres as it passed, sampling conditions and transmitting data across unimaginable distances. Others whispered of more ominous motives, testing planetary defenses, or even demonstrating destructive capability on a scale humanity could scarcely comprehend. Evidence for such claims was thin, but the questions refused to fade. The truth for now remained hidden in the silence between the stars. Part of the fascination with 3 Atlas lies not only in its physical mysteries, but in the mirror it holds up to human psychology. When confronted with the possibility of an external threat, be it a comet, probe, or something stranger, people respond with a curious mix of fear and unity. Studies in social behavior show that common dangers often encourage cooperation, breaking down divisions that seem intractable in times of peace. Avi Loeb himself suggested that the viral interest in 3 Atlas may spring from this instinct. The mere possibility of alien technology, whether real or imagined, unites people across cultures in shared wonder and unease. It creates a story larger than nations, larger than politics, a story of survival and of humanity's place in the cosmos. In a fractured world, the idea of contact, friendly or hostile, serves as a rare narrative thread tying us all together. And yet, for all the speculation, caution must anchor imagination. Science is built on restraint as much as curiosity. With only 3 interstellar objects ever observed, the sample size is far too small to draw firm statistical conclusions. Probabilities may appear staggering, 1 in 500, 1 in 20,000, but those numbers lose weight when drawn from such sparse data. Outgassing, though often irregular, can mimic deliberate acceleration under certain conditions. Measurement errors, though unlikely given the scrutiny, cannot be ruled out entirely. Responsible voices remind us that extraordinary claims demand extraordinary evidence. And for now, 3I Atlas teeters on that uncertain edge, strange enough to provoke suspicion, but not yet proven beyond the natural. Still, even the skeptics can see that 3 Atlas occupies a category of its own. It is a case study in anomalies, an object that resists neat classification, that challenges the models built to explain comets and asteroids, that hovers at the boundary between the explainable and the uncanny. For that reason alone, it commands attention. As the critical window of September 2025 approaches, anticipation sharpens. By then, the object will have passed near Mars, and its trajectory will be clear beyond dispute. Will it strike the planet in a blaze of catastrophic energy, skim past with unsettling precision, or reveal new mysteries in its behavior as it brushes the inner solar system? Across the globe, agencies prepare for all outcomes, though humanity possesses little real power to alter the course of such a visitor. Our role for now is to watch, to measure, and to learn. Whatever 3 Atlas ultimately proved to be, it has already bestowed something invaluable. It stretches the boundaries of our imagination, forcing us to confront the possibility that the universe may still hold forces and technologies we have not yet grasped. It dares us to consider, without flinching, that intelligence beyond Earth may be watching, probing, or passing silently by. It reminds us that our solar system is not a closed sanctuary, but an open thoroughfare, a cosmic crossroads where wanderers from the stars occasionally appear. And so 3 Atlas continues its journey, pulsing every 17 minutes, carrying its secrets into the void. It may be nothing more than a peculiar comet behaving in ways that strain our models, but remain natural in origin. Or it may be something else entirely, a machine older than our species, executing a mission written in instructions we cannot yet decode. The truth is suspended between probabilities, poised on the line between coincidence and intent. Until that truth is revealed, humanity can only do what it has always done: watch the skies, calculate the risks, and wonder. And in that act of wonder lies the essence of science itself. The courage to face the unknown and the humility to admit how much we still have to learn. For now, 3 Atlas streaks onward, pulsing every 17 minutes, carrying its secrets in silence. It may be nothing more than a peculiar comet behaving in ways that strain our models, but remain natural in origin. Or it may be something else entirely, a machine older than our species, executing a mission written in instructions we cannot yet decode. The truth is suspended between probabilities, poised on the line between coincidence and intent. Until that truth is revealed, humanity can only do what it has always done. Watch the skies, calculate the risks, and wonder. And in that act of wonder lies the essence of science itself. The courage to face the unknown and the humility to admit how much we still have to learn.
Awe.